Hello guys, welcome to my channel. In this lesson, I will show you examples on how you can multiply and divide rational expressions. All right, let's go ahead and get started with the first problem. So number one, so we are looking at multiplying x to the third power plus 2x to the second power plus 4x divided by, get 2x squared plus 11x minus 21 times x squared plus 5x minus 14 divided by x to the third power minus 8. All right, okay, so I know this looks intimidating, but I think it'll be fun. It will only be fun. So one way I would suggest you do this problem here is to color code them, color coding, and I will just take them one by one. So let's go for the red one. So the red one is x to the third power plus 2x squared plus 4x. So yeah, this polynomial here all has a variable x. So then that means I can factor x very quickly. So I'm going to factor x to the left, and then I have x squared plus 2x plus 4. And this is exactly enough right now. So I will just stay here because I know this part here is prime, and this I don't have a way of factoring that easily. So I'll just leave that alone. So I'm done with the first part. So I'm going to color code. So I'm taking green now to do the denominator for the first fractional expression, radical expression. All right, so I will do my 2x squared plus 11x minus 21. All right, to do this, let's go together and just learn how to do this factoring. So 2 times negative 21 will be negative 42. So this is the process of factoring. Okay, some students use box method, and that's how they understand it. So this 11 here will be the sum that I'm looking for. So I want to be able to decompose negative 42 into two factors that add up to 11. Okay, so now I know that I have a lot of factors for 42, but I'm just going to go straight to the point. I know that 42 is 11 times 3. 14 times 3. So since I have a negative result, so I will just do that as 14 and negative 3. All right, because I want to be able to add 14 and negative 3 to get what? 11, but then multiplying that will get me to what? This result. You see, by multiplication, I get negative 42. By addition, adding them together, I get what? 11. So now, to factor the trinomial, it means I'm going to replace the 11x by 14x minus 3x. So that's what I'm going to do to be able to factor the trinomial right here. So 2x squared. Instead of 11x, I would now replace by this number. It'll be 14x minus 3x. And then I'll move over to negative 21 and just write that. So now I can factor by grouping. So 2 and 14, 2 goes in 2 and 2 goes in 14. And then x and x, so that x goes. So then I'm left with x plus 7. For the second part of the grouping, so I'm going to factor negative 3, and then I get x positive 7. But okay, to notice that when you factor a negative number, then you have to change the preceding negative number or positive number to its opposite. All right, so now this is what we have. And then I can just group these two together to get 2x minus 3 all in x plus 7 for the two factors that overlap. Okay, so this is how you would do the denominator here. So let me go for the light blue here, right here. You have x squared plus 5x minus 14. So have x squared plus 5x minus 14. Again, I know the coefficient of x squared here is 1, and I'll just multiply to that. I get negative 14. Again, I'm looking to play that with positive 5. So I know two factors of negative 14 that gives 5 when added. That would be 7 and negative 2. So 7 times negative 2. So I'm just going to use comma. So 7 times -2 will give a -14, but then I can just combine them as 7 minus 2 to get 5. So what that means is that this 5x here will be replaced by 7x minus 2x. That's what I'm going to replace that 5x by, so that I can factor the trinomial. So that means I have x squared plus 7x minus 2x minus 14. So that gives me x factored out from this group, x plus 7 in that, and then I'm going to factor -2 from that group so that I can get x. Again, you have to change your sign quickly to +7. So now I'm going to put these two together, x minus 2 and x plus 7. So this is how you factor this expression right here. And we are going to go to the last one, which is the dark blue. All right, the dark blue is x to the third power and minus 8. So here I'm going to show you what we can do here to factor this expression. So just like I explained before, when we had x squared minus 4, for example, we were able to factor that into, rewrite that into x squared minus 2 squared, right? And then we see that this is a difference of 2 squareds, and we can write as x minus 2 and x plus 2, right? So this is the case of squares, well, the difference of squares. But here we have the difference of cubes because 8 is a cube. All right, because we can write 8 as 2 to the third power. So that means x to the third minus that. Okay, so x to the third minus 2 to the third can be factored in a special way, just like this. In this case here, what I'm going to do here is to show you how you can quickly factor that. To factor this expression here, you will keep x minus 2, because this is the base here. The base is -2. Okay, now the base is 2 over there. So then you can multiply that 2. You take your x squared, right? Of course, the base here is still 2, so you have positive 2x. Okay, and then you have to now square your 2 so that we can get 4. So notice that when I expand this result, it will give x cubed minus 2 cubed, which is x cubed minus 8. So we got to look at how we can reversely do that. So x times uh, x squared will be x to the third power. X times 2x will be 2x squared. And when you distribute finally, you get positive 4x. And then you go with your -2, and that will be -2x squared. And then when you go with this result here, what you get will be -4x. And then when you go with -2 times 4, you get -8. And you can see how this are going to cancel out. See, and that, and 4x will go with that because these are their opposites, and you're left with x to the third minus 8. So this is one cool way to factor difference of cubes. Okay, so now we are done factoring everything. So which means we get all the factors together and then just see the ones that we can cross out. All right, so I am now going to go back in order of which that I did my color coding, and then I will show you how we are finishing with these results. Okay, so let's go for the red one. So the red one, we factored that here into x times x squared plus 2x plus 4. And I'm going to divide that by the green one. And the green one was factored into this result. So we got 2x minus 3 multiplied to x plus 7 factored form. And then we did the light blue, and the light blue was factored into, and we're multiplying now, the light blue here was factored into x minus 2 and x plus 7. And then finally we did the dark blue, which is the difference of cubes, which factors into that result. And then it was, let's say, be very careful here. We got x minus 2 in x squared plus 2x plus 4. And this is all we have so far, so good. So we are now going to take just look at the factors that are common and just begin to reduce them. So this is the goal right here. So I can see that x squared plus 2x plus 4 is appearing on both numerator and denominator. So I can cross those out. So I can also see x minus 2 over here and x minus 2 in the denominator. So those cross out. Again, if I keep looking, I see x plus 7 and what? X plus 7. So meaning that all I have left will be x, gotta be careful. So x divided by 2x minus 3, 2x minus 3, and this will be your final result. So we can try one more. We can try another example. Okay, let's go ahead and try another example. So in this example, we are going to look at example 2. Uh, let's look at example 2. For example 2, we're going to look at y to the third power, because sometimes we just get used to different variables, divided by y to the second power minus y minus 2, and then we're going to divide that by y squared minus y plus 1 divided by y to the second power minus 4y plus 4. Again, the trick is to, just color code and see how we're factoring that. So the first one is y to the third power plus 1. So what I'm thinking here is that it must be, I'm suspecting that this expression here can be factored. That's what I'm thinking. It can be factored maybe into something relating to this expression right here, or maybe to this one, or maybe to this one. I don't know. So, but I'm just gonna go ahead and try it out. So, for this is what you call like a different sum of cubes, okay? Because even one can be written as 1 to the third power, and it remains the same expression, right? So, in this case here, what I'm going to do here is to try out y plus 1 and y squared uh, minus y plus 1. So this is what I'm thinking. I'm just thinking that maybe I can factor this result. Let's see. So let's try it out. So y times y squared will be y to the third power, and y times negative y will be negative y squared, and y times 1 will be positive y. And then I'm going to go with 1. 1 times y will be y squared, and 1 times negative y will be negative y, and 1 times 1 will be 1. And then you can see clearly how these opposites will go out quickly, and then you end up with y to the third power plus 1. So which means what we suggested was good. So that means y plus 1 multiplied to y squared minus y plus 1 will be the factored form of this result right here. So we're done with the red one. So we are going to go for another color. So we're going to color code with green. So we color code this one with green. And then we're looking at y squared minus y minus 2. Okay, let's see how we can quickly factor this. We know there's a 1 here. And then I can multiply that and see what I'm getting. Okay, let me see. If this is possible, it would be great. So I get negative 2 when I multiply. But then I get a negative 1y. Yes, I do negative 1. So I'm looking for two factors that add up to negative 1. Okay, two factors for negative 2 will be negative 2 times 1. All right, so that means negative 2 and 1 can multiply to give negative 2. But then again, if we add them together, we are going to get negative 1. So this is good. So that means my factors that would replace my negative y, okay, or negative 1y would be negative 2y plus 1y. Okay, let's just make sure we're writing all the coefficients that are invisible here. It helps sometimes. So now I am going to go ahead and just write or y squared, or which is 1y squared. If I wanted to write that, yes, okay, you can do that. All right, so I'm going to replace the negative y or negative 1y as negative 2y plus 1y, and I'm going to throw in my -2, which is this number right here. So to factor that, I see that I get a y here and a y here, right? So that means y in y minus 2. Good. And right, now move to the second part here and group it because I've just done this one. So the only common factor with 1 and 1y and -2 will be +1. So, and that gives me y minus 2 factored, right? Okay, again, I am going to collect these two guys to get y plus 1 together, and then the factors repeating here would overlap to y minus 2. All right, so I'm done with the green one. So I'm now going to go to the light blue. For the light blue, it will be this expression right here. So light blue is y squared minus y plus 1. And it looks like I do not need to do anything right here because I already have a pair for that. That would reduce that. So one trick is to notice that we do not need to factor that anymore. In fact, maybe that's a prime. And if it's a prime, how can you even factor that? So that means this is already good, checked. So we don't have to do anything for that. And then we would lastly go to the dark blue. The dark blue is this expression right here. That expression is y to the squared minus 4y, yes, plus 4. Okay, so now we're looking at how we can factor this. Okay, let me go ahead and just say 1 here and multiply that to get +4. And I'm looking at how that would give me -4 and factored from. Maybe this is a perfect square, I'm thinking. So now if I do -2 times -2, that gives me +4. And if I do -2 plus -2, that gives me -4. Oh, all right. So that means I can actually replace this guy here by -2y and -2y. So that means this result here will be y squared minus 2y minus 2y plus 4. So that's how I'm going to factor this trinomial right here. So now group to get y in y minus 2 factored. So again, factor -2 and get y, and then change the sign because you're factoring a negative factor, and it will change to -2 right there. So again, you're going to group, which is y minus 2, and the overlapping is also coinciding with y minus 2. So this is a perfect square. All right, so we have everything factored. So we're going to keep an eye on this. Keep an eye on this result here. Keep an eye on this result. And keep an eye on that result over there. So now we're going to collect them now and see what we have going on. So which means everything is going to give us, going to lead us to the red one first, which is y plus 1 in um, y plus 1 in, let me see what we're doing here, y squared minus y plus 1. And then you're going to divide all of that by the green one. And the green one is y plus 1, y minus 2, right? And then we say we're dividing that by the second part, which is the blue one. The blue one is actually y to the second power minus y, because we did not have to do anything to that. I'll just keep that, you know, brackets. Okay, just keep that everything together. And the dark one is this result right here, which is y minus 2 and y minus 2. All right, so this is how I have that in factored form. But then if I'm very quick enough, I can actually just reduce this 2 for now. Well, I keep going forward to see what I have left. So I have y squared minus y plus 1 divided by y minus 2. That's what I have. Let's just keep that together. But again, you have to do your keep change flip. Yes, I think that can help you. So you have to multiply and move this up, and then you move that down. Okay, because this is division, right? So it'll be y minus 2. Yes, y minus 2 over y squared minus y plus 1. So of course, when I'm solving this problem, I'm just thinking there has to be something that I can so cross out. Again, you have to keep in mind that when you do your divisions, you have to be extra careful. So now you can see that this result right here matches with this result here. So again, we're going to cancel the factors like that. Again, we see that y minus 2 matches with one of the y minus 2s, and that's all we can do. Your final result will be this result right here, which is y minus 2. So again, this will be the end of showing you how to multiply and divide rational expressions. So we have some orders that are really, really easy to do. Well, maybe just to add one more example, maybe an example uh, maybe say 2x squared divided by x to the third power minus 1, then times x squared plus x plus 1 over say 4x. Okay. All right. So an expression like this one. So to solve this expression, let me show you on the next slide on how you can solve this expression. Let's go ahead and try it on the next.